Hello and welcome, I'm your CodeMonkey. In this lecture we're going to create a kitchen object parent, meaning that the kitchen object will know where it is and the counter will know if something is on it. This is important so that later on we can pick up a kitchen object from one place and drop it in another. Okay, so here we have our player. I can move towards this counter, interact with it, and yep, spawn a tomato. Then on this one spawn some cheese. Okay, great. But I cannot do anything else. In fact, if I interact a bunch more times, really, all I did was just spawn a whole bunch more cheese. So instead, I want to be able to spawn some cheese and then pick it up. So let's think about exactly what that means. We want a kitchen object to essentially be placed on a specific place. Based on the design that we're trying to implement, we're never going to have a kitchen object just randomly strewn around the world. We're not going to have tomatoes all over the floor. Instead, the objects will always need to be placed somewhere, and that somewhere can be either a counter or it can be being held by the player. So essentially that means that each kitchen object is going to have some kind of parent that it's attached to. We're going to make sure the counter knows if there is a kitchen object placed on top of it, and we're also going to make sure the kitchen object itself knows where it is. So first let's do that logic over here on the counter. So on the clear counter script, let's keep a field for a kitchen object. So just a simple private of type kitchen object. Then when the player interacts with it, by the way, we can get rid of these debug transforms, debug logs, we no longer need them. Okay, so when the player interacts, so if the kitchen object is null, if so, then we're going to spawn it. Then when we spawn it, let's assign it. So this one equals the kitchen object get component of type kitchen object. Okay. So if that one is null, we spawn it and we assign it. And just with this, we should have fixed the issue where we can spawn infinite objects. So over here, I can interact, and now if I interact a bunch more times, and now look in the hierarchy inside the clear counter. And I go inside the counter top point. Nope, there's only one tomato. Okay, great. So with this, basically, we made the clear counter know if there's something on top of it. Now let's do the other side. So let's go into the kitchen object and make sure that it knows where it is. So over here on the kitchen object script, let's add a simple field for a counter. So private of type clear counter for the clear counter. And now let's just basically make two functions, one to set it and one to get it. So a public void set clear counter. And we're going to receive a parameter of type clear counter. Okay, great. And then we're going to have a public return a clear counter for the get clear counter. And we're just going to return our clear counter. And on this one, just set this.clear counter equals this clear counter. Alright, so on this function we're assigning this field, and on this function we're returning this field. So now back on the counter script, we get the kitchen object reference. So on this one, let's call setClearCounter and pass in this one. And if it is not null, so if there's something on top of this, let's just do a debug.log. Let's go onto the kitchen object and get the clear counter. So we should be able to click once and spawn an object, and click twice, and the second time we should be able to see the name of this clear counter. Alright, so over here, let's approach and click, and yep, it spawned. Now click again, and yep, we've got the message. This one is on the clear counter. Okay, great, so far so good. So the counter knows if there's a kitchen object on top of it, and the kitchen object itself knows where it is. Now let's add some logic to be able to change a parent counter. So over here on the clear counter script, we basically just need to call the setClearCounter function with a different counter reference. So just for testing, let's add a serialized field for the second counter. So clear counter for the second clear counter. Now we're doing this just for testing, just to make sure the logic works before we come up with a more general system. So just for testing, let's come up with some input. And again, for testing, using the legacy input manager to get something quickly up and running is a great thing. So let's quickly get a button input on the counter. So let's make a private void update. And for testing, we only want the testing to work on one counter. So let's also add up here just a bool testing. And then on update, if we are testing and we have the input.getKeyDown on, let's say, the T key. So if you have that, then we can run some kind of testing code. So let's say, for example, if the kitchen object is not null, so if we have something on top of this kitchen counter, let's go into the kitchen object and call setCounter, and let's pass in the second clear counter. So basically with this, we should be able to interact to spawn an object, and then press the T key, and we should be able to see that object be set to a different parent. So here in the editor, let's just set that. Let's say this one is our main counter. So let's drag a reference to the second one, the second clear counter, drag it, and make this one the testing script. And also just to verify that it worked, over here, let's do a get on the clear counter. All right, so let's test and see. Okay, so here we are. Let's approach this one, interact, and there you go, spawn tomato. And now if I interact again, yep, it says the tomato is on this clear counter. Now if I press the testing key, yep, there you go, the tomato was moved onto the other counter. Okay, so the parent changed, the logic worked. However, obviously we have two big issues. The first one is just a visual. You can see the object is still placed on top of this counter, even though technically now it belongs to this one. And the second issue is that this counter still thinks that it owns this kitchen object. And this other counter does not know that it now owns this object. So we need to sort all of that. First, for the visual, it's actually very simple. Here when spawning, we are spawning it inside the counter top point and then setting the local position to 0. So whenever we move to a different second parent, when we do that, we can just ask that second parent to return the counter top point and move it there. So for that, let's make a function to return that. So public, we're going to return transform. So get the kitchen object follow transform. So this is going to be our counter top point. So let's return the counter top point. Then let's go into the function on the kitchen object when we set the clear counter. So over here on the kitchen object on this function, so we set the clear counter. Then let's modify this transform.parent, go into the new clear counter in order to get the kitchen object follow transform. And again, let's make sure to set the local position back into vector3.0. Okay, so with this, when we set the clear counter to a different one, it should automatically teleport to the other counter. So let's test. So here we are, and first let's interact with this one. There you go, it spawned. Now if I press the testing key, and if there you go, it does move visually. Okay, great, so far so good. However, the counters still have the wrong data. By the way, here's a quick Unity tip. On the inspector, you already know that you can only see the public and the serialized fields. However, there is actually a way to look at private fields. On the inspector on the top right, there's these three dots, and if you click on it, over here you can modify it into a debug inspector. And when you go into this one, yep, this one does show all of the private fields. So you can see, for example, on the clear counter, so that's the right one. This one over here, the kitchen object, is indeed assigned. And we can go into the other one, and we can see this one has it as null. So debug inspector is really useful in these kinds of cases. If you want to inspect any kind of private fields, you can go to this and see it. Now let's swap back into the regular inspector. And let's fix that issue by notifying the counters that the object has changed. So over here, basically we have two options. Over here on the clear counter, when we modify the parent, when we tell the kitchen object to go to a new parent, when we do that, we can make the new parent responsible to updating itself, or we can just make the kitchen object itself be the one responsible for notifying the new parent. Both approaches can work. Personally, I think it makes more sense for the kitchen object to handle itself. So we just call this function to set the new parent. And when this happens, basically this kitchen object needs to tell the old parent that it is no longer there and needs to tell the new parent that it is on there. So on the counter, let's make some function to set and get a kitchen object. So over here on the clear counter script, let's go down. Let's make first one to set. So public void set kitchen object and receive a kitchen object. And just do this dot kitchen object equals this kitchen object. Okay, great. Then let's make a getter. So public return a kitchen object, get the kitchen object, and just return this kitchen object. Okay. Then let's also make one just to clear it. So public void clear kitchen object. And this one just sets the kitchen object into null. And finally, just a nice simple function to test if this counter has anything on top. So just a public bool has kitchen object. And over here, we just return if the kitchen object is not null. Okay, so some 4 very simple functions. Now if we go into our kitchen object script, over here when we tell it to change the parent, let's first go into the current parent and clear it. So let's first of all do a quick test for null. So if this .clear counter, which is the current parent, so if this one is not null, then we go into the current parent, so the clear counter, and we tell it to clear the kitchen object. And then we go into the new parent, and we tell new parent to set the kitchen object, and the kitchen object is this one. Now here, be very, very important, don't make the mistake of clearing the wrong counter. Keep in mind that over here, this .clear counter, this refers to the previous clear counter, whereas the one in the parameter, this is the one, this is the new one. So make sure you clear the kitchen object from the previous clear counter before you assign it, and then you set it on the new clear counter. So be very, very careful here. Make sure you don't make mistakes between the quote-unquote old clear counter and the new clear counter. Okay, so that's it. Basically, we have this function to set the new clear counter. So set the new parent. We clear the kitchen object from the old clear counter, we add it to the new one, and we update the visual. Now, we can also add some nice safety checks here just to make sure we never make a mistake. The kitchen object should never be set to a parent that is already holding something. So before we set the kitchen object, before we do that, let's make sure that one is empty. So over here, just do an if the clear counter, so that's a new one, if this one has a kitchen object, then it already has something on there. This should never ever happen, so let's do a debug.log error and say counter already has a kitchen object. We're going to eventually add tests to make sure that this never ever happens, but having the error here will be helpful just in case we miss something. So if it has a kitchen object, we're going to fire an error, but this should never happen, so we just set the error, update the visual, and so on. Okay, so finally, let's just go over here into the clear counter script. And down here we have the interact action. So we instantiate the kitchen object. We're currently repositioning it, and then we're setting this field, assigning it to this one. Now we made the kitchen object responsible for doing all that, for modifying the position and for setting the field, so we don't need to do this. Instead, we really just need to go and get the component of that, and just pass in set clear counter, and pass in as this one. So we no longer need all of this, now our code is much more simple. Also importantly, up here we were previously setting the clear counter and then doing a debug.log, but when we set it to the new one, that is actually going to clear this field, so if we leave this, then this is going to throw a null reference exception, so let's just get rid of this log here, we no longer need it. Okay, so let's test and see if all of our logic is working. Alright, so here we are, let's go to this one, interact to spawn it, okay, great. And once again, we can look in the debug inspector, so let's put it on debug, look at this clear counter, so that's the right one. And yep, there you go, it does have the kitchen object. And if we look in the other one, yep, this one has null. Okay, great. Now if I press the testing key, yep, visually it did change. And if we look at the counter, so if we look at the old one, so that's the right one, this one is at null. Okay, that's great, correct. And if we look at the new one, yep, this one does have the reference. All right, awesome. So now that we are correctly changing the kitchen object parent, for example, we can now interact again with this one, and yep, it does spawn a brand new one. And of course, if we try moving it to the other one, then we should have our error as intended. This one is currently already occupied with kitchen object, so we should not be able to drop something on there. But if I press the testing key, yep, there you go, nice error. Okay, so that's great. We're basically going to fix this error later on when we add checks to make sure the object can only be spawned when it can be spawned. But for now, all of our basic logic is working. We can spawn an object and change the parent. Alright, so with that, here we have added a really important feature to our game. That is the ability to know where a kitchen object is. Now the next step is to enable the player to be able to pick it up and drop it somewhere, so let's do that in the next lecture.